Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. Also, in this video we are going to perform a calculation that relate to the Kc value. Alright, so let's read the question together. At 500 Kelvin, the Kc for the reaction is 33 for the reaction of formation hydrogen iodide. Assume that the initial concentration for both hydrogen gas and iodine gas is given, and find the concentration of the reactant and product at equilibrium. Meaning that the initial concentration only for the reactant. If we have the initial concentration, so we need to tabulate an ICE table. So what does it mean by ICE table? It is a table where the first column is initial, C is the changes, and E is equilibrium. So first we need to write tabulate a table first. So we have hydrogen plus I2 the first column we have the initial concentration, so we put a concentration initial which is 6.0 10 to the power of negative 3 molar for both, meaning that at the beginning of the reaction there is no product form. So the second one is the changes, so we can use a triangle or the concentration change. Okay, so now how to write the changes? In front here we don't have any figure, meaning that it is 1, so the concentration of the reactant will reduce. So reduce indicate by the negative sign, reduce 1 which is X, and for the iodine also reduce negative X. But for hydrogen iodide the concentration increase, indicate by plus sign, and it is 2x because we have 2 in the stoichiometry is 2. And then the concentration at equilibrium is 6 10 to the power of negative 3 minus x. This is 6 10 to the power of negative 3 minus x, while this one is 2x. Okay. So this is our concentration at equilibrium. We have the Kc. So how to relate the concentration at equilibrium with Kc? Right, so now we can write the Kc expression. The Kc is equal to the concentration of hydrogen iodide squared over the concentration of hydrogen gas and the concentration of iodine gas. We are given the Kc value which is 33. So 33 is equal to 2x is the concentration squared over 6 10 to the power of negative 3 for hydrogen, and also 6.0 10 to the power of negative 3. This one also 6.0. Can you solve the quadratic equation? And finally you will get 2x value, x1 and x2. Try to solve the quadratic equation. Okay. You supposed to get 2 value of x, but which one is possible? X1 is not possible because the initial concentration is 6 10 to the power of negative 3. If we put the x1 as our changes, it is wrong because it will give a negative concentration. So the right value of x is x2. Okay, so this one is not acceptable. Alright, so how to calculate the concentration at equilibrium? So we can put the concentration of H2 at equilibrium is equal to the concentration of iodine at equilibrium, which is 6.0 10 to the power of negative 3 minus 4.45 10 to the power of negative 3 molar. So the answer is 1.55 10 to the power of negative 3 molar. And what about the concentration of hydrogen iodide? So the concentration of hydrogen iodide at equilibrium is equal to 2x, which is 2 times 4.45 10 to the power of negative 3 molar. (8.9) 10 to the power of negative 3 molar. Okay, so the same situation ataupun the same method you can use if you are given the Kp and you have the partial pressure of each gas initially and at equilibrium. Right, so that's all. So see you in the next video.